Okay, so I want to write down now what is called a multiplication rule. Okay, so what's the multiplication rule? The multiplication rule says the following: the probability of A and B, right? A intersect B means what? It's the probability that both A and B occurs, right? It's the probability that both events occur. So the probability that both occurs is the same as the probability of A given B multiplied by the probability of B. Okay, that's the multiplication rule. Now, why is that true? Well, that's actually coming from. So why is this true? Well, because we know that the probability of A given B is the same as the probability of A intersect B divided by the probability of B, right? So that is our definition of the conditional probability of A given B, right? Well, do you see that the multiplication rule is exactly the same as that equation, right? All you have to do is multiply both sides by the probability of B, right? So in the equation star, if you multiply both sides of the equation by P of B, you exactly get the multiplication rule, right? Is everybody clear? Are we okay with that? Now, and as an application of this, let me do an example. How many of you have played with playing cards? 52 cards? Okay. So you know there are 52 cards. How many different suits? And how many different denominations for each suit? 13, right? Okay. So let's do an example. Let's say pick 2 cards from a deck of playing cards. Is that how they say it, playing cards? Okay. Let's say what I want to know is what's the probability that both of the cards are from a deck of playing cards without replacement. Without replacement. So that means you're not, so the way you're doing it, you're picking one card at a time. So one way to do it is with replacement, which would mean that you pick a card, you look at it, and then you put it back in the deck, and then you pull another one. Is that making sense? So here what I'm saying is without replacement means you pick a card and you do not put it back in the deck, okay? And then you pick the second card. Okay, so you're picking this. Then the question that I want to ask is, what's the probability that both are clubs? one of the suit is called clubs, right? Okay. So does anyone want to answer that? What's the probability that both are clubs? Yeah. Yeah. So why is he saying what he just said? Well, this means the probability that the first card is a club, and the second is a club, right? So this is and. And means, you think about two events. The first event is the first card is a club. The other event is the second card is a club. So you're asking what's the probability of A and B. So I can use the multiplication rule and say this is the probability that the I'm going to write it this way. The first is a club multiplied by the probability that the second is a club, given that first is a Is that making sense? This is exactly the multiplication rule, isn't it? This is exactly the multiplication rule. So if you look at the multiplication rule, the probability of A and B is the probability of A given B times the probability of B. So in my example, I am taking B to be what? I'm taking B to be the event that the first card is a club, and A is the event that the second card is a club. So if you use A and B in that way, this is exactly what I get. And what's the probability that the first is a club? There are 52 cards in the deck, right? So what's the probability that the first is a club? There are 13 clubs out of 52, right? Well, and then what's the probability that the second is a club, given that the first is a club? 12 over, I'm sorry, 51, yes. Okay. Is everybody okay with that? Okay, so now the general multiplication rule. The general multiplication rule says the following. The general multiplication rule is also known as the chain rule. So this is what it says. So this is like the multiplication rule when you have the intersection of 3, 4, or more events. So what's the for any events A1, A2, ... AN, the probability of A1 intersected with A2 intersected ... intersect AN is the same as the probability of A1 multiplied by the probability of A1 given, sorry, not A1, A2 given A1 times the probability of A3 given the intersection of A1 and A2. Okay, what will be the next one? What will be the next one? Probability of A4 given A3, yeah, good. So the last term will be the probability of AN given the intersection of A1 up to AN minus 1. Is everybody clear? So how is it gonna, how do you derive this? Well, you're basically applying the multiplication rule repeatedly. Is that making sense? You apply the multiplication rule repeatedly. So just to illustrate that, as an example, what's the probability of A1 intersected with A2 intersected with A3? Well, you can start with by saying that this is the you can think of A1 intersect A2 as one event. Okay, so in that case I can say by multiplication rule the probability of A3 given A1 intersected with, sorry, let me erase that. Let me write here. So this is the probability of A3 given A1 intersect A2 multiplied by the probability of A1 intersect A2, right? That's one application of the multiplication rule. And then you apply it again, you get if you apply it again, you get the probability of A2 given A1 times the probability of A1, right? And then all I did is I wrote them in the opposite order. So this is the same as the probability of A1, probability of A2 given A1, probability of A3 given A1 intersect A2, right? If you have four of them, you can again, if you have four events, you can divide it into three events and one event, apply the multiplication rule, right? And you just keep doing that. So maybe let me do one more time. So what's the probability of A1 intersected with A2 intersected with A3 intersected with A4? Well, this is the same as the probability of A4 given A1 intersect. So I'm thinking of A1 intersect A2, A3 as one event, A2 intersect A3 multiplied by the probability of A1 intersect A2 intersect A3, right? This is one application of the multiplication rule. And then the probability of A1 intersect A2 intersect A3, you can again keep applying the multiplication rule like before, but we have already done that, so I don't have to do too much work here. So we already know what is P of A1 intersect A2 intersect A3. So that's the same as the probability of A1 times the probability of A2 given A1 times the probability of A3 given A1, A2, and then the probability of A4 given A1, A2, A3. Is everybody okay with that? So this is how you can obtain the general multiplication rule. One remark that I want to make is that a lot of the times when I get tired of writing intersection sign, a lot of the times instead of writing, so I might write A1, A2 to mean A1 intersect A2. Okay, and more generally I might write, A1, A2 dot 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 AN when I mean A1 intersect A2 intersect dot 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 intersect AN. Is that making sense? This notation that on the left, this notation that I have here, this is just a notation so that I don't have to write those intersection signs all the time. Okay. Whenever I have to write that too many times, I will just avoid that.